Imagine a planet that behaves like a freshly baked cookie, shrinking and cracking as it cools. This is precisely what has been happening to Mercury, the closest planet to the Sun, over billions of years. But here's where it gets controversial. Scientists have long debated just how much Mercury has shrunk, and recent research might finally provide some clarity. Mercury, much like a loaf of bread, has been contracting as it loses heat since its formation around 4.5 billion years ago. As the planet cools, it develops thrust faults, cracks in the rocky surface that help accommodate the shrinking process. These faults are similar to the cracks you might see in a cooling cake, but on a planetary scale. Scientists can estimate how much Mercury has shrunk by analyzing how these faults have uplifted parts of the planet's surface. However, previous estimates have ranged widely, suggesting that Mercury's radius has shrunk anywhere from about 1 to 7 kilometers. This discrepancy has puzzled researchers for years. To address this issue, researchers Lovelace and Klimczak developed a new method to estimate the shrinkage caused by cooling-induced faulting. Unlike previous methods, which rely on the length and vertical displacement of uplifted landforms and can produce varying results depending on the number of faults included, the new method focuses on the largest fault in the dataset. By measuring how much this fault accommodates shrinkage and scaling that effect, they can estimate the total shrinkage more accurately. Using this approach, the researchers analyzed 3 different fault datasets, one with 5,934 faults, another with 653 faults, and a third with just 100 faults. Surprisingly, regardless of the dataset, their method consistently estimated a shrinkage of about 2 to 3.5 kilometers. When combined with prior estimates of additional shrinkage due to other cooling-induced processes, the researchers concluded that Mercury's radius may have shrunk by a total of 2.7 to 5.6 kilometers since its formation. And this is the part most people miss. These new estimates could significantly enhance our understanding of Mercury's long-term thermal history. Moreover, the same methodology could be applied to study the tectonics of other planetary bodies, such as Mars, which also feature faults. This groundbreaking research was published in AGU Advances, and it opens up exciting possibilities for future studies. Do you think this new method will change our understanding of planetary evolution? Share your thoughts in the comments below. For more breaking space news, the latest updates on rocket launches, and skywatching events, join our space forums and keep the conversation going. If you have any news tips, corrections, or comments, feel free to reach out to us at community@space.com. Sarah Stanley, a freelance writer for EOS, has a background in environmental microbiology, but covers a wide range of science stories for various audiences. She has also written for PLOS, the University of Washington, Kaiser Permanente, Stanford Medicine, Gladstone Institutes, and Cancer Commons, a nonprofit that works with cancer patients.